very, very massive. It has a mass that's 10 times the mass of the Earth's atmosphere. And so you have a very, very thick layer of gases. So it's thicker than the air as we know it. The particles in the air are also very small, and so I would characterize them more as a haze than as a fog or clouds.
The haze is 200 miles thick, resembling something else on Earth.
From the outside, it appears essentially opaque, like a big orange ball. But as the Huygens probe descended through the atmosphere, it's transparent enough to be able to see the surface features as it fell through. But it's not unlike a hazy day here in Los Angeles.
It's not the color of the atmosphere that most intrigues scientists. It's the composition. Nitrogen and methane, the same gases they believe made up much of Earth's early atmosphere.
The idea that Titan's atmosphere mimics the atmosphere of early Earth 4 billion years ago is something we're very, very excited about and interested in, and it's one of the things we're studying very hard in our laboratory. Let's see if we can get this aligned. What do we have? Oh.
At the University of Colorado, Dr. Margaret Tolbert is simulating Titan's atmosphere in her lab. Might it, too, have the necessary ingredients for life?
In this experiment, we're trying to simulate the chemistry that goes on high in Titan's atmosphere where the haze is forming. And so what we have is a reaction chamber here, and all that we have in there is nitrogen and methane. So the two most important components of Titan's atmosphere. And then we're just going to flick on a lamp, and that lamp is going to simulate the sunlight hitting Titan's atmosphere.
Incredibly, Tolbert's research has shown that Titan's atmosphere, when stimulated by sunlight, begins to produce organic compounds. To scientists looking for life beyond our planet, this could be big. As scientists scour the galaxy for signs of life, there are some exciting results from within our own solar system. Saturn's moon, Titan, seems to have the necessary ingredients. Testing at the University of Colorado has shown that when sunlight interacts with Titan's nitrogen and methane-rich atmosphere, organic compounds are created.
So these organics are floating down to the surface of Titan, and you can see them in the pictures, and who knows what they're doing once they're there. They could be providing energy to some new kind of life.
Further research is needed to determine if there really is life on Titan, or if it might someday develop. Although its atmosphere resembles early Earth, the environment is vastly different.
It's cold. It's 300 degrees below 0 Fahrenheit, and there's no liquid water. So that's a big difference between early Earth and Titan.
The lakes and riverbeds on Titan were carved out of the ground by something. There's no liquid water on the moon, so what flows on this terrain?
The hills on Earth are made of silicate rocks, whereas the hills on Titan are ice and methane ice. The river channels on Titan are formed by methane rain, as opposed to the Earth river valleys formed by water.
Liquid methane, it seems, rains down on Titan, or did at one time.
On Titan, it is so cold that gas has liquefied, and there are coastlines and rivers and all this terrain shaped by moving rivers of methane. It's just completely intriguing.
Methane is the principal component of natural gas, butane, and propane, all sources of fuel.
There's a lot of hydrocarbons. It might be very light hydrocarbons on Titan. And there's a lot of it. And it burns if you put it in contact with oxygen. So there's a lot of energy out there.
Enough on the surface of this huge moon to supply all of Earth's needs for a very long time.
Well, here's this tremendous supply of natural gas on Titan. Boy, wouldn't it be great to go out there and tap into it and bring it back? But I think that you would find that it would cost you so much to go out and get the methane and bring it back that you would never be able to effectively power anything on Earth with it. Effectively power anything on Earth with it.
While Titan is Saturn's largest moon, one of its smallest may be even more exciting. It's a brilliant ball of ice and rock called Enceladus.
It's a tiny object. It's only about 300 miles in size, so that's what, about the eighth the size of our own moon. And we've never seen a body that small that has activity on it.
This activity was discovered in 2005 by Dr. Carolyn Porco and her Cassini imaging team. One photo seemed to suggest that jets were coming out of Enceladus.
It seemed very likely to the members of my team that it's possible that these jets are actually geysers. They're erupting from pockets of liquid water not too far beneath the surface.
The closest thing we have on Earth to Enceladus is something like Old Faithful Geyser here at Yellowstone National Park, which is shooting water vapor and water about 150 feet into the air. The geysers on Enceladus are erupting water vapor hundreds of miles into the air because of the much lower gravity there and the fact there's no atmosphere holding them in.
Many geysers have since been discovered, all in a region of Enceladus's southern hemisphere.
They are coming out of these fissures, these big cracks that go on for about 135 kilometers, something like 80 miles of cracks.
We call them tiger stripes because when we first saw them, they really looked like the stripes on a tiger. There are 4 areas that seem to be ridges or kind of active geologic areas, and the plumes seem to be coming out of these areas. And we've counted about 20 or 21 plumes.
Southern Enceladus is covered in cosmic Old Faithfuls.
Who would have thought that an ice ball about the size of Texas would be alive with plumes and geysers? I mean, it's astounding.
Enceladus is heated in its interior by the tides of Saturn. The Earth's moon is pulling on the Earth's oceans and distorting their shape and producing the tides that we're familiar with here on Earth. But on Enceladus, the planet Saturn is pulling on that moon, and as Enceladus goes around in its orbit, that pull is changing and the ice inside Enceladus is creaking and groaning and rubbing against itself and creating a lot of heat through friction. We think it's that frictional heat that is producing the evaporation of the water ice that is then escaping through these cracks and making the geysers that we see there.
And there's more. Enceladus's eruptions have clarified a theory of what powers one of Saturn's rings.
We knew there might be jets, something coming from the surface that was injecting material into orbit around Saturn to form the E-ring.
The E-ring is furthest from the planet, about 74,000 miles away.
It happens to be just at the same orbit, the same distance from Saturn as Enceladus. And so it really suggests that it owes its origin to Enceladus. And thickness of the E-ring sort of matches the thickness of particles that were ejected from the south pole of Enceladus.
If these geysers disappear, so might the ring. Ultimately, the liquid jets suggest that there is water on Enceladus. And perhaps something else.
So the search for water is not that, oh, one day we'll be thirsty, so we'll have something to drink. The search for water is guided by our interest in the search for life. It's that simple. Follow the water.
Saturn's moon Enceladus is one of the most exciting and least understood places in our solar system.
Enceladus is a really strange place. The strangest thing that got people's attention first is it's very, very bright. It's the whitest object in the solar system. And we now realize that it is covered in freshly fallen snow, which is the ice that's fallen back from these geysers onto the surface.
And it's that ice that has scientists excited.
Possibilities there are amazing. The search for water in our solar system is ultimately a search for life. You look for water in the hopes that maybe there will be life.
Because of the presence of ice, some experts believe the search for alien life should begin on Enceladus.
It has a lot of other molecules in it, a lot of other exotic things, which show us that there's probably aqueous chemistry going on underground. So there's a lot of little percolating kind of chemistry going on, and maybe you could get biology, maybe, and so maybe we should go look.
This is kind of the holy grail of modern-day planetary exploration, to go and seek out those environments in the solar system where life might possibly have gotten started. And we just stumbled upon it. Is that exciting? You know, I mean, of course it's exciting. It's the kind of thing scientists live for.
We know the composition of the gases that are coming out because we've flown through them with the spacecraft, and we've got the composition including carbon and nitrogen and all those goodies that you need to make life. And then we know there's a source of energy from the frictional heat or the tidal energy from the frictional heat or the tidal heat in the interior, and we can see the heat on the surface. So all these elements are there that might be sufficient to sustain life if life could have got started there. So that makes Enceladus a very exciting place.
But what kind of life?
We're not talking sushi, you know. We're not talking lobsters and fish, we're talking microbes. I think that's about the best that we can hope for on a moon like Enceladus. If we ever discover such life in our solar system, it's going to be the simplest possible. It's going to be bacterial, something like it.
Even the discovery of something small would be a huge event.
It would change everything that we think and know about our solar system, the universe, and ourselves.
Much of what is known about Saturn and its moons has come from the Cassini satellite that was inserted into the planet's orbit in 2004. It is currently touring its rings, moons, and the planet itself. By 2008, Cassini will have made 70 trips around the gas giant.
Putting an orbiter around a planet and being able to hang out there and monitor the system and all the different elements of the system for a long period of time, I mean, that's the best way to study these bodies.
Scientists on a daily basis process the information sent back from these close encounters.
In addition to the camera, there's a radar that can send its radio waves through the clouds, get an echo off the surface, and make an image of the surface. And then there's spectrometers to measure the composition and other infrared devices to measure temperature. So it's a very comprehensive spacecraft.